Well, good afternoon. So, anything new on campus? I've been away all day. I just got back from a meeting. So I'm sure you've heard our president is moving on to Ball State University. He'll be here with us through the end of July. I did want to, take this chance to say that, don't freak out. I think we're going to be all right. Specifically with this, this is a good example, right? We've got our strategic plan, and it is our strategic plan. And again, I've heard, many people refer to it as President Ferguson's plan or President Ferguson's Blue Sky Plan, and he certainly was central to its creation and implementation. But it is our plan. It's the university's plan. It was an engaged process, involved people in thinking it through, in developing it, and certainly in the implementation. And as I've talked about before, it's been integrated into the life of the campus. Each vice president has got some responsibilities for making sure that we move forward on the strategies. Speaking for myself, for the ones that I'm responsible for example, this one, we're moving forward full steam ahead. And the conversations that we'll have about signature and emerging programs and how they influence our thinking about the university moving forward, that I don't see any change in that. So today's meeting is at least as important as it always has been. So today, since the focus is on research and the signature research areas, I have asked Vice President Carol Kim to lead an MC. I've done that, I think it's appropriate, and also because I have no more jokes. I used up my jokes, or my clean jokes. So ones that could be videotaped. So I'd like to ask Carol to come forward and keep us going.
Thanks, Jeff. So this afternoon, we will have presentations from 5 signature research areas. And these research areas have been, there was the process with the review group. We had internal constituents as well as external reviewers. And we developed the criteria and then reviewed all of these research proposals. What we have now are 5 signature research proposals that will be presented today. And later this summer, we'll be presented with the emerging research and the emerging educational areas. I have to say that yesterday's presentations, I think a number of you were able to make the presentations of the signature educational areas, or academic areas. They were superb. I was very impressed. Everyone did a great job. After hearing those proposals, I was very proud to be part of the UMaine community, and wow, it was very impressive. And so I'm sure that these research areas will also be equally impressive, and I'm looking forward to listening to the presentations this afternoon. The order,
it's on the PowerPoint, just look at those slides.
okay. So, oh yes. So we want to have the opportunity to have discussion and comments from this audience, but also just so that you're aware, the presentations are being recorded. And just as we did with some of the open forums that the provost presented, I presented one as well. They are going to be posted on the provost website so that the community, so the faculty and staff, students that are not able to join us today will be able to review the slides or the presentations. And then there's also the opportunity to comment, not necessarily in this room, but through the website. And that website will be up for
About a
week and a half or so. Okay? So, and I think that process has been very helpful so that everyone can share their opinions and suggestions. So again, today we'll have the opportunity to ask questions and then to read the full proposals. The full proposals will be posted on the Provost website as well. So today we'll be starting with sustainable forest and forest-based economy, and then move to a presentation from the climate change group, marine research solutions, STEM education research, and advanced materials for infrastructure and energy. Okay. There, and the designated presenters for those groups. So with that, we will, I think, Hemet will be starting.
Thank you, Carol, and thanks for coming. We are what we like to call a cluster, research cluster, because we have quite a few existing centers, existing programs that have been around for a while. Before community engagement became a fashionable word, we were already doing it as what we call CFRU, where forest landowners were actually putting money where their mouth is based on the acres of land they own. At our PDC, which is Process Development Center, in 1984, when there was a R&D bond and state built a $3 million building, our pulp and paper industry folks put $3 million worth of equipment in there so we could have state-of-the-art pilot paper machine. In our paper surface science program, there are 12 to 15 industrial members who put their membership dues on the table and do pre-competitive research without micromanaging it. Talk about private stakeholders partnering with the university. And this is long before these became slogans. So what we are talking about is, on one side, sustainable forest and resource management. CRSF is the center which took over cooperative research unit for the forestry. On the new wood-based materials and processes, we have 3 different centers there. And on commercialization, and we are one of the bold universities that stand in front of people and say, we're gonna take our research from bench scale to commercialization. We're gonna babysit mills if they need babysitting, so that our technology can go from the 3rd floor of Jenness Hall to the mill floor and can be validated on a commercial scale. And you will see that we have a team of leaders who is working together on these particular things. And why should you care? Care because we have more trees than people, as they say, and that forest brings in significant amount of economic impact for the entire state of Maine. There's not just few large landowners, but there are the small woodlot landowners that own 1/3 of this land and supply wood in the current industry. So it's a very diverse population of wood suppliers. There are current wood users like pulp mills and other product manufacturers who also are interested, so they can find out what new things they can do with the wood besides doing the same thing they have been doing for many decades. Why are we distinctive already? I told you about the pilot paper machine that was put in. Right now our machine is booked 18 months ahead of time. People wait in line to get a couple of weeks of time on the pilot paper machine, because we have built a reputation that our machine might be running only at 150 feet per second, while the real machine works at 6,000 feet per second. That's more than 55 miles an hour. We make paper that's only 13 inches wide. Real paper machines make paper that's more than 200 inches wide, wider than a highway traffic lane. But those people who are making paper wider than a traffic lane, going 55 miles an hour, 24/7 every day, still need to come to the university's pilot machine if they want to try new technology, and this is where that technology gets validated. Nobody will let them come in a commercial paper making area without they have validated technology at a facility that we have. So that gives you an example of why we have built reputation where we get clients from all over the world. Coding and printing falls in the same area. We get clients from all over the world. Wood composites, what we used to fondly know as AEWC, before people came and put whitewash on it, and the name is now only name of a building. That wood composite has been there for a long time. Forest management, wood to jet fuel. Let me talk about wood to jet fuel. A lot of people still don't appreciate that. We have actually made several liters worth of jet fuel starting with wood residues. I don't know if you can believe that, but what matters is Air Force Research Lab has tested that fuel and told us that we have already met the specs for blending it into the jet fuel. That's what puts us on the national map, and soon you will see in Old Town, wood to fuel technology will go commercial. In terms of productivity, if you have read our report, we have shown what kind of publications, technical reports, and working directly with the client kind of work we do. We have 34 active faculty members, and we get our own soft money staff. That means we raise the salaries, we raise the fringe benefits, we pay the overheads, and keep the operation going. Why we are so confident? Because we are building on what we have for many, many years. Look at how long these particular process development center to technology research centers have been around. Total 77 years worth of sustainable operations. Presidents come and go, programs keep on running. Leveraging 1 to 11 right now. How do we do that? 60% from the government, state and federal, 32% from the industry. Don't take it for granted. Not a lot of people can pull that one. 8% from the university. So we are kind of trying to immunize ourselves that second floor of Alumni Hall can do the least amount of damage to this operation. So think about it. Look at this word cloud. I was gonna call that blue sky, but I'm not gonna say that today. But when provost is standing around, think of the next joke, and a lot of these words are floating around. We will show you before we end, how does this all put together? Whether we are talking entire forest community, towns and villages that depend on those working forests, or are we talking about spray-dried nanocellulose that we are making right now, several pounds a day. Different scales, the trees that grow 40 feet tall to the nanoscale material that comes from the wood. I think we will talk about a lot of different scales, a lot of different activities. If you see a lot of these programs and how they are interconnected without losing their identity. We do not jump on the bandwagons and just throw ourselves in. We keep on doing what we believe in, and we collaborate, cooperate, and compete wherever it is appropriate. All those overlapping areas that you see, that's where we work together. The non-overlapping area, we keep on doing what we like to do in spite of the fashions of the day. So if you look at this again, Process Development Center in 1987 started working with pulping and paper making. PSSP program, Paper Surface Science, joined in with coding and printing. Engineered Wood Composite program, worked with structures, oriented strand boards, and now getting involved with nanocomposites. Center for Research for Sustainable Forest brought in communities, trees, saw logs, as well as the pulpwood. FBRI brought in the overlapping areas with its operation in Old Town, and people willingly started working together. Talk about it this, one forester, one wood scientist, one chemical engineer, and one paper maker went to a bar and said, I think we got to do FBRI 10 years ago. We did it with a $7 million grant from National Science Foundation. Right now, we have the latest on spray-dried nanocellulose. We have already supplied research community worldwide 4,000 pounds of nanocellulose material because you need large enough quantities before you can develop applications for such material. UMaine is the only place where you can go and get this nanofibrillated cellulose. That was done with $1.5 million of USDA grant, and we have been serving community of 120 different clients using that facility. So let's look at some real numbers. I told you what comes from internal funding, from state and federal government, and from industry. There are the numbers in the real report, and how 34 faculty are spread around chemical and biological engineering, School of Forest Resources, chemistry, School of Economics, and civil and environmental engineering. Multidisciplinary people working together when they find the right chemistry with each other, and when they see the applications they would not have tackled on their own. This is the team, and today Steve Shaler is out here in the audience, Doug Boosfield is out here, and I think Amy Luce will walk in. She's the one who manages the Old Town operation. Bob Wagner happens to be in Idaho because he's part of a 10 university consortium, and Mike Bilodeau is in Washington, D.C. because he's on a panel on cellulosic nanomaterials. So just quick introduction of what each program does. This involves forest itself, the CFRU I talked about, family forests and small woodlot owners, and in general population that is interested in conservation land. So this is long beyond just silviculture and forest management. These programs have evolved, and that's why they have become sustainable. The mission is broad and stakeholder-driven research. We compete just the old-fashioned way. We write proposals, we go into competition, and we bring the money home. The Process Development Center, you see the paper machine, you see the processing equipment, fee for service. We have paying clients that come to us to get the services of professional staff. And that's how we have built a reputation. Self-supporting. None of the employees there on our university's budget. Mike Bilodeau raises the soft money to keep the operation going. Paper Surface Science program, mainly based on pre-competitive basic research, graduate student, master's and PhD oriented, but close interaction with industry because it's their membership dollars that are making it possible. Peer-reviewed publications, technical presentations, and coming up with new techniques that industry can benefit from. Very fundamental research that industry would not have done in their own operations. Wood composites, I think we talked about it, international reputation. They had collaborations in Chile long time ago. Oriented strand boards, they had done actual testing on a mill scale, and they have their own pilot line. Multiple sources of funding from the government, and also doing fee-for-service operation. Well-balanced portfolio. FBRI talks about the converting existing pulp mill infrastructure, building on it, and allowing them to do fuels, chemicals, and advanced materials. That building that you see here, the tall one is 110 feet tall, and the next to it is a 90 feet tall. That's where University of Maine's pre-pulping extraction technology was commercially demonstrated in Old Town, where the mill on its own spent $1.5 million of their own money. And what we had done in the third floor of Jenness Hall with just few grams of material, and what we had done on the first floor with few kilograms of material, they did it there 1,200 dry metric tons a day, 24/7, and bunch of college professors were doing mill trials on a commercial operation. And Amy Luce, who just walked in, made it possible because she had worked 13 years in that mill, and she knew the operators there, and those mill trials were run from Jenness Hall. Real world experiments on real world facilities. And Technology Research Center, that building that is in Old Town, is a 40,000 square foot, 35 foot tall ceilings where we can do operations on industrially relevant scale. And that's why we get our own distinction. People come here because we have faculty support, but they also know that we're going to solve their problems at the scale that they are interested in, so they can go home, get the design data, and decide for themselves whether technology is ready for actual deployment. So that's where I stop and open for questions.
So questions for Hemet?
Might as well keep it up. Emmett, I'm curious, if you were to define this initiative outside of the centers on which it's based, if you were to more generally define the initiative, could you do that for me, please?
Sure. If you think of wood is the nature's best engineered material in itself, you want to use wood as wood. That's what the lumber industry does. If you can't use wood, you want to use the fiber. That's what the pulp and paper industry does. And if you can't use the fiber, you want to use the chemicals in it. And that's what the new biorefinery kind of operations are trying to do when they're going to make sugars from the wood or they get chemicals from the wood. So this is how you can add value to the wood that is a renewable resource. And that's why we brought forestry folks who can do the modeling on a 75-year time scale, on a landscape scale, with chemists who are looking at few grams of material and trying to find out what enzyme will work on a particular wood component. Ability to work on multiple scales, both in space and time, is what allows this collaboration to do.
Paula, please. So if this project were selected and as it moves forward, it's not going to necessarily in future be limited to the centers that you indicated. It could involve other participants as you move forward.
And I'll give you an example. The policy folks who work with Margaret Chase Policy Center are slowly getting involved through the School of Economics. And we got School of Economics people involved first, and now we're getting policy folks involved. So it's an evolving. And that's how the way we evolve and self-organize ourselves as new opportunities came, and we decided synergy where it is appropriate without sacrificing the core of existing programs.
And could you say a little bit, one of our criteria is about integration and how all the research area integrates student learning. So we could talk a little bit about that.
It happens at 3 different levels. Undergraduate research experience, where first and second year students can work just 4 hours a week just for exposure, no strings attached. If they don't like it, they don't have to come back next semester. These facilities, and we have unique physical facilities that really excite students. That's one. Juniors and seniors are honors thesis candidates who really want to devote 10 hours a week or something like that, can choose to do their own thesis. They can get a faculty mentor, they can get support from our professional staff, and then they can build their honors thesis or undergraduate thesis or independent study. So this is at an undergraduate level. Our students have been co-authors on refereed technical papers even before getting their diploma. Our undergraduate students have been co-inventors on the patents even before getting their bachelor's degree. So they are not just there washing test tubes and beakers, they are part of the research team, properly recognized, and they really build their own career based on the value of that experience. Graduate students usually work with the faculty advisor. If the bench scale work is enough, they can do it in their own labs. But if they need to go larger scale, they work with Emil Lewis or Mike Bilodeau, and our staff will help them to take that next step. So I think that I can talk principally from chemical engineering, but forestry folks do similar things. Steve, you can add.
Another example, there's in the second 3-year phase of the NSF REU program. Dave Nevant's one of the principals on that, Doug Gardner. And those students are doing everything from life cycle assessment, working with economics, looking at biology of tree roots to fuels, composites. So though that's a tough program to get into, and those students are in 4 or 5 different departments. So,
And that gives us national visibility. We take 10 students and we have 70 applications or something.
Actually, had 140
Yeah.
applications for 10 students, and it's international.
So
They
we are
exchange
being
with
the
Chile.
place to go.
Thank you.
Thank you.
Next up, we'll be hearing from the Climate Change Group, and their designated speaker is Paul Majewski.
That was very impressive, Hem. Thank you very much. Okay, just to orient us, we live someplace down here. The Earth's atmosphere is about 100 miles thick. We live in the lower, basically few hundred feet, maybe a mile of that. No matter what you do, you cannot escape the climate system. It's in this room. If you want to talk about the climate of a room, it's in your body, it's everywhere. And when it changes or doesn't change, it has an immense impact on your life. At the University of Maine, we look at climate in a very, very broad way. We talk about the physical, the chemical, the biological, and social aspects of climate change. That's very rare. There are very few institutions in the world who actually do this. And it's a constantly expanding field. People come from the fields of chemistry, physics, anthropology, mathematics, computer science. Every single person has something to offer, and every single person in this room, or one way or another, understands how climate change impacts us. The building block for climate is weather. And I don't think I have to explain to people that the weather has been certainly prominent in the last few years, and it will continue to be this way. We're going towards more and more unstable weather conditions. And as this happens, there has been a dramatic increase in the cost of weather catastrophes. This is just one way of looking at weather catastrophes. Work is done by Munich Re. Munich Re and Swiss Re are the 2 largest reinsurance companies in the world. They're the companies that insure the insurance companies. And they take catastrophic events like this very seriously for obvious reasons, as do the people who live there. The University of Maine has a whole series of climate change strengths. And while the Climate Change Institute is not the only place in the university that conducts this sort of research, we certainly are at the heart of it. We're involved in literally every aspect of climate change, from climate reconstruction, along with many partners, who you'll see in a second, natural climate and its impact on climate and humans and ecosystems, adaptation, sustainability, applied information transfer. You can read the rest. The Climate Change Institute has been around for 42 years. We are one of the oldest climate research institutes in the world. We return on the order of about, depending on how you count it, $10 to $20 for every dollar that the state gives us. And we have about an 80% success rate in federally funded proposals. We have about 100 accounts per year that come through the institute that are handled by our administration. And an 80% success rate is a very, very dramatic thing, and it was even 40 years ago a dramatic thing. The typical success rate for NSF competed proposals, and remember, these are not mission-oriented proposals. These are totally driven by the principal investigators' creativity, are typically closer to 10 to 20%. These are our partners, both within the university and all over the world. Within the university, we have a large number, and I'll point out the ones that we have the strongest academic affiliations with. School of Biology and Ecology, Earth and Climate Sciences, Computing and Information Science, Anthropology, plus many others. We support close to 60 graduate students that get their academic degrees in these programs. And because we have shared positions financially, several of us with these academic units, we have a great deal of involvement in how those academic programs are structured, and likewise, they have a great deal to do with how we structure our institute. Series of emerging associations with many elements on campus. I'll just point to 2. One is Veemi, the Virtual Environment Multimodal Interaction. where we've talked about new ways of expressing how the climate and the environment change over time and over space. We find ways we're looking for ways to express the experiences that our students have in very, very remote parts of the world. The other, there are many, School of Policy and International Affairs where we share an IGERT that discusses for 25 new PhD students the relationship between abrupt climate change and policy, and a building association with the business school. Within Maine, we have plenty of partners. This is just a partial list. I won't even attempt to read it. With the federal government, several national laboratories, I didn't even put our funding agencies like the National Science Foundation, NOAA, EPA, NASA. We work with, I would say, over 40 different institutions within the United States, and we work and have led programs that included 25 institutions from the United States, and we work in at least 30 different countries around the world and have led research programs of 8 to 10 other countries as leaders, not just as participants, but as leaders. One of the things that we're well known for is being able to have a very global view, both in space and time, of how the climate system operates. We've made many, many significant contributions that I'll give one example as we go on in a little bit. But the types of things that we've done, we're the first to actually put together the different elements of the climate system and how they operate. The first to understand that the climate system does not operate linearly, that it operates abruptly. I'll give an example today. We're the people who actually, early investigators in our institute, were the first to demonstrate why ice sheets can in fact collapse very quickly and raise sea level. And we've also done a tremendous amount of work in differentiating the relationship between human and natural forcing of climate. Enough detail for that. The example that I'd like to show you that requires this global understanding is exactly what's happening right now. The fact that Eastern North America is cold, in a northern hemisphere that is warming, and in an Arctic that is warmer today in parts of it than it has been in the last 12,000 years. These are discoveries made by the University of Maine climate change research teams. These are significant things. I just spent the last 2 days as a keynote lecturer for a large meeting of generals and admirals, including General Jacoby, who is the military leader for all of North America, including Canada. And there's tremendous concern about what's happening in the Arctic. Maine is in a very important situation. It's the door to the Arctic for eastern United States. We've probably had more polar explorers come out of Maine, more polar seafarers, places like organizations like MSKIP, which is an Icelandic shipping company, are now beginning to work out of Portland Harbor. Maine, coastal Maine, for a whole number of reasons, is going to become a very important area, and it is largely because of the opening up of the Arctic. At the same time, our weather is dramatically impacted by the opening of the Arctic. A little bit closer to home directly, although everything that happens globally and hemispherically impacts Maine, we're involved in many, many different things. We've run workshops like CC21, where we brought together scientists, artists, writers, musicians, policymakers to talk about how climate change impacts them, particularly in Maine. We developed, Ivan and Fernandez in the back of the room in particular, along with George Jacobson, developed a document that's the Bible for climate change in Maine, Maine's Climate Future. In late October, we will be hosting a conference called Climate Adaptation and Sustainability, in which we will provide the very first software framework that can be utilized by Maine communities, eventually for states, and eventually for the world. We've already started applying these sorts of techniques to places like Tajikistan in order to be able to empower people at the local level with an understanding of how the climate change system works and develop themselves scenarios for how they'll deal with things in the future. We've developed software like Climate Reanalyzer and 10 Green, which allow us to, not just us as scientists, but the public, to have transparent views of both physical and chemical climate change, plus the models that are coming out of the Intergovernmental Panel on Climate Change. And even closer to home, we've done tons of monitoring. Our weather research forecasting models have been used to demonstrate how Lyme tick will spread all over Maine in the future, unfortunately. This is Lyme tick, and also how heat frequent changes in the number of extreme events will impact Maine. Maine's particularly sensitive to extreme heating. We have the oldest population in the world, in the country, of which I'm clearly one of them. And they are subjected easily to extremes in heat. We're used to the cold. We're not used to the heat. We don't have air conditioners, a variety of other reasons. And then finally, as has been made clear by the Pentagon, although we've been talking about this for a long time, and which General Jacoby talked about over the last 2 days, climate change is a major security issue. It's a dominant security issue. It doesn't necessarily appear in a lot of political discussions because it has been politicized in some way, but there's no way that one can get around the fact that it impacts our health, economy, the frequency and magnitude of catastrophes, and all of us geopolitically. So climate is something you can't escape. Climate changes, it always has. It's changing faster now than it ever has before. All of you, and certainly all of your children, will be living in a world, forget about just plain warming, in a world that is very different than the world that we have today. And every single discipline, every single career that they're involved in will be related in some way to this new climate. Thank you.
Questions for Paul?
I'm looking at Owen.
Paul, I'm certainly not surprised that you're selected, or your team has been selected as a potential signature program. But what I'm curious is, given the successes and recognition you've had to date, what do you see your primary concerns as you move forward? What are your new initiatives that you would bring out that would help advance the university's standing?
Thank you for asking that, because it's something I left out, and it's a very important question. 20 years ago, you could barely pay an audience to come and hear about climate and climate change. Now, of course, a lot of the things that were considered technical nomenclature are now becoming well known to people, things like vortexes and El Nino, southern oscillation. To keep up with the field of climate change over the last 40 plus years that the Institute has, we have constantly had to evolve. Most recently, we've developed an interest and a need to be able to work with large data sets, cyber infrastructure, to be able to utilize these, make them transparent for the public. The sort of things that we need to now start moving into in the future are much heavier monitoring programs. We have some. We don't have, for example, a monitoring program of any significance whatsoever other than some small localized EPA stations in atmospheric chemistry. Air quality is very, very important. In the United States, the levels of cadmium are not healthy. As a consequence, children are exposed to much higher incidence of autism in this country because of airborne cadmium. Similarly, we have very large small particulate levels. So we're embarking, along with with Ellie Roden and her team and school, in programs related to health. We want to embark with Len Kay in programs related to aging, so that we can provide a basis for what might be expected, not necessarily in heat stroke, we don't know that part of it, but what are the stressors? How much can we expect? We want to become far more heavily involved in policy. We've started to do this certainly through the IGERT. It's a strong and building association, but we want to be able to take the information that we have and not only empower, as Ivan and George Jacobson have done, Maine communities, but also policymakers. That's a lot harder. And we also want to build much stronger ties with the School of Economics and the Business School, because it's essential to be able to translate what we do into things that people can understand. They need to know how much they are really paying for a gallon of gasoline. They need to know how much they're paying for their health care and how that could be changed if we had better air quality. So and where we go in 5 years, I bet if you ask this question in 5 years, I guarantee you we will have done those things that I've already mentioned, those associations. But it'll become even bigger. There are going to be problems related on an international level to the distribution of water towers. Water towers are places where there's water surrounded by places where there isn't water. Lesotho is a water tower in South Africa, country in southern Africa surrounded. It's a small, weak country. When the surrounding richer, drier countries need water, the question is, what are they going to do? Tajikistan, where we work, same thing, except they have ice. They're surrounded by China, Iran, Uzbekistan, Afghanistan, and Mali, the same problem. So there's a big world of not only international climate adaptation and sustainability planning, but a lot more interaction with, in particular, the military, which is why I was so happy to be involved at the meetings in the last 2 days. And that association will only get stronger. I think that if you were to bet on, we all bet on the stock market, we all assume it's going to get stronger and stronger. We know what the trend is for climate, and if we can reduce the uncertainty in our understanding of climate for the future, we have the potential for building a much happier and healthier world than we have. And the two big things that really impact people in terms of changing climate are their health and their wealth. And so those, if I had to come up with 2 words, those are the 2 things that we're going to try to promote at the University of Maine with our colleagues here, using expertise that we don't have in outside.
Thank you for an interesting presentation. Climate change is so closely related with global energy consumption. I did not see energy kind of feature very prominently in your presentation, but I would like to ask if you can explore a bit on the nexus between this signature area with the parts of energy, which is going to come later on in one of the presentations, as well as opening up the Arctic means we are talking about more energy production from that area as from the marine environment. So there is that nexus with the marine sciences. So can you talk about how you're going to connect with these other signature areas?
Well, you're absolutely right, and it's great that you pointed that out. Energy is clearly, how we deal with energy is one of the, not only the potential ways we're going to mitigate, but more pragmatically, it's the way that we're going to adapt. We do have an association with the School of Marine Science. Faye and I work together, talk about things. It is not as strong as it needs to be. We need to find a closer way to collaborate. I actually have an appointment in SMS. Faye has an appointment in CCI. We have several shared people. We need to explore that in more detail. Energy in the more well-defined way, we haven't gone as far as we should. We started to work with Habib preliminarily in doing something that I think is extremely important. Imagine a world in which Habib and his colleagues put in X number of large turbines in a marine environment and the wind stops. Well, the wind won't stop entirely. If it did, the sun wouldn't be shining. But in which all of a sudden the calculation that they made for the wind drops by 10, 20, 30%. And in fact, that's exactly what's happening with the westerly winds, which are the primary drivers for wind speeds in the Gulf of Maine. The wind speeds are decreasing, and the westerly winds are moving farther north. So one of the things that we can do, and we hope to explore in more detail, is a projection for where in the Gulf of Maine is the best place to put windmills, so that you can be sure that over the next 20 to 30 years you have the best chance of sustaining. We could certainly develop a much stronger relationship with the biofuel discussions, because we can be talking about, forests don't change that fast, but they certainly will change in the next 20, 30, 40 years. And we need to have discussions about what we project might be those futures and what they think and what implications this may have. So that's an excellent question. And I think these last two questions really do point to the fact that literally when you start scratching at climate change, it's everywhere. You can talk about it related to everything. The point you brought up about energy, though, is clearly one of the most important.
Great. Well, thank you.
Thank you.
Next up is Marine Research Solutions, and Fei Chai will be presenting. And not to be outdone by Jeff, he might have run out of jokes, but I have this one we're setting up. So a biologist, a physicist, and a chemist decide to go on vacation together. They go to the beach, and the biologist is just mesmerized by the sea life in the water, and is caught up in that, doesn't pay attention, drowns. The physicist is mesmerized by the waveform and just is not paying attention, wades into the water, doesn't pay attention, and he drowns. The chemist witnesses this, whips out his notebook and writes, biologists and physicists are insoluble in water.
Carol has to wait until my turn to tell the joke, right? So you get the message. According to the schedule, my time is up because of 50 minutes, right? So nevertheless, I have this buzzer in my hand. I will try to stay on time with this. So I'm going to talk to you about the Marine Research Solutions. We toss around the names, but as you can tell by the end of my presentation, there's really no good acronym in there. But we tried, and we think about the marine stars, the marine sciences, the technologies, and the resources, and the society. Sounds pretty neat. And what I'm really going to tell you about is our vision to form this a consortium or coalition related to the marine areas at the University of Maine. And what is our vision? What do we want to try to accomplish? It's really 4 words. I gave you this, and before I start, is really this correlation is to fostering the communication, improving the coordination, the strengthening the collaboration, and we are inclusive. All right? So the marine research is a truly interdisciplinary and multidisciplinary. Why? Because we count the names. There are 90 faculties or so, and they spread out in the staff, and spread out in 20 different units here on campus. And in the proposal, last 5 pages, we list about the 90 people with their areas of expertise, their affiliation, and their potentially associated clusters, as you can tell, right? And if we, let's show this, it's really the center of this is the School of Marine Sciences, because about 1/3 to 40% of this marine expertise are affiliated with the School of Marine Sciences. If I put all the 20 units on this page, the School of Marine Sciences will be very, very smaller. The Gulf of Maine, the coast of Maine, is Maine's heritage. They play a very, very important, a vital role in the economy, in their culture, and whether it is the traditional commercial fisheries, it's on the order of about $1 billion, and then that's the industry. You can put a price tag on that, but sometimes it's very difficult to put a value for the tourism. They come to Maine is because we have a nice, pristine views in the Penobscot Bay. We have clean water, and imagine if you have the pollutant from the industries, how are you going to put the price tag on that, right? This is very important. I think now we have the vast resources, the renewable ocean resources, and then now the climate change impact on the high value, the coastal property down the south. So think twice before you buy that beach condo somewhere south. So think about this is tremendous. So the School of Marine Sciences will have a group of people, primarily oceanographers, to start studying, understanding the Gulf of Maine by monitoring our environment. And I used this yesterday. It's really called the University of Maine Ocean Observing System, called the UMOOS. In our business, acronym is everything. So think about it, UMOOS, right? So what is really this? A set of buoys, and it has about 14 at the peak. Now we're down to about 7. We're monitoring the temperature, salinity, the wind, and then the precipitation, the visibility. Now we're adding the sensors, oxygen, the nutrients, the pH, the carbon dioxide, the CO2 fluxes. So into this set of moorings that provide us the understanding, the physics, the biology, the chemistry, and etc. Not only that, this is an operational system. It's one of the kind. It's one of the best in the country, in the world, because since 1998, Neil Pettigrew and his group putting the first 2 moorings in the Penobscot Bay, it got 98% of the data return on an hourly basis. So think about this big data, how much the data that come in. The information is the tremendous for our understanding our environment. Not only that, but it also has the practical use. It saves people's life. It's protecting the people's life. Here is an interesting view graph. So a cup of coffee plus the mooring equals lobster fishing. Because 4 o'clock in the morning, our website got hit the most. We wondered, who is in the morning, 4 o'clock, check our buoys data, right? So the lobstermen, they get up, they get a cup of coffee, check on the mooring, check on the conditions, whether they can go out fishing safely or not. You see this, how you can put the price on the people's safety. This is a tremendous value. It's not only for the understanding, but also has a practical use. Because of this continuous of data stream, we can understand the long-term changes in the ocean and also in the air. So this is one of the examples, the temperature anomaly in the Gulf of Maine. And you can see this, we call the 2012, the ocean heat waves. The temperature in the Gulf of Maine from the surface down to the bottom was about 2 to 4 degrees warmer than any of the years before, the long term. So, and then it has a huge impact on the lobster fishery, the biology. You see the catch, and then you can see the impact on the cheap lobsters, flooded the Canadians market, and etc. It triggered the international relations, right? You can see from the changing of the ocean conditions to the lobster biology and the fishery, impact on the market, impact on the international relations. This is the story Andy Pershing was able to put them together, from the changing climate down to the economics and etc. So he put a group of School of Marine Sciences faculty as well as the GMRI scientists together and successfully got this NSF grant called the Coastal Seas for $2 million for the next 3 years. They're going to study and follow this. We have many of really successful the researchers in the School of Marine Sciences, and as well as the other units. I don't have the number for them, but I have there's a grant dollar amount numbers for the School of Marine Sciences, including Emmanuel, he just left. This is the trend. This is for the grant dollars we generated just by the School of Marine Sciences faculty. So this year, end of April, we're about to close to $7 million. I know for sure we have a couple of large grants coming in by the end of this fiscal year. It's going to be $8 million. How that compare with the rest of so you have to be relative. So I want to draw your attention. The award that for the past 5-6 years, the SMS roughly generate 15 to 20% the total grant award. It generated 20 to 25% the total UMaine's indirect cost return, IDC. So those to put you into the perspective, not only we're successful generating grants, we also have a reputation, international reputation, through the scientific citation index. We just conducted a project with Jim Bird at the University of Maine Library. We, at the end of March, the H index, if you know what it is, and then for the School of Marine Sciences, it's 108. It's one of the highest units on campus. It compares very competitive with other similar institutions. The ocean renewable energy is one of the clusters that involves not only the School of Marine Sciences, the engineering, the social, the communication, all the various different units on campus. So you can see we have been very active to address those issues. And then not only you can put structures in this ocean, how that impact on the local communities. I think that's the part of the successful story on the tidal energy. They start with the local communities and get back to the engineering, get back to the monitoring, and put them all together. So Gail Zielinski played a very, very important role, not only with doing the research. This summer, Gail and then her colleagues are going to the summer school. They're going to do a 2 weeks long, a summer school, just focus on these issues. So therefore, we want to reach out to the other units, the scientists at the other units, to form this correlation that is to address really, to understand, that's the scientific part of it, and not only the natural science, the physics, biology, chemistry, but also the social, the economic side of it. We think this is very, very important. We have a group of very strong scientists in the School of Marine Sciences. We collaborate with the School of Economics. Our most recent hires actually is joined the position. So the second part, we want to engage the stakeholders. We want to come up with solutions, not only the engineering solutions, but also the social, the economic solutions. But lastly, we want to use this for our teaching, and I used a couple of examples yesterday, and all those research projects involve both undergraduate and the graduate. So how are we going to approach to this? And you got 90 people, 20 different units. It's hard. Therefore, we think we use the cluster approach. So we got science and technology, we got the society, economics, and we got resources. The living marine resources, renewable ocean resources. And so far, we formed about 11 clusters, right? So basically, this is a team of the people, they have a common interest, they can get together, they start with a coffee at the unit before they go to the bar, because they may end up bar fight. So think about it, right? So you have to let the people to get to know each other to form the team, and sometimes it may not work. So we have the ocean modeling and prediction. We not only predict the ocean conditions, as a modeler myself, I'd like to predict other things as well. So there you can see this is a part, again, this correlation, and then this is really going to fostering the communication, improving coordination, let the teams to work together, and then figure out who can contribute what. And then we're strengthening the collaboration, and then we're inclusive, and we're going to be a project-based approach and cluster-based approach. Thank you.
Questions for Faye?
As you know, since you presented yesterday, School of Marine Science is being considered as a signature educational program. Does it make sense to you to separate these two? Is there enough differentiation to say there's a SMS educational signature? I mean, outside of, I know the call for proposals was structured this way, but I'm asking you to talk a little bit about what the relationship is between educational initiatives and research initiatives, and if you see them as separate or connected.
Can you define what the mean signature programs? Joking aside, I think the research and education cannot be separated completely. And it's very important for the success of our education program. That's what I mentioned yesterday. doing the research with the faculty for the undergraduate students. But the research part is what I said, is really the interdisciplinary and multidisciplinary nature of marine science. It does not involve just the school marine sciences. It has to involve the engineering part, the climate change part, and the economic part, which we do not have the strength, all in the school marine sciences. So therefore, I think stay separate, it means a lot of advantage for the other units to collaborate and then go after some of those large projects and grants.
So I'm going to follow up on your bar fight. So you know, and some folks know, so that it was the review team that suggested you get together with folks in mostly in marine engineering. So my question for you, when you got done fighting in the bars, how much of this do you, how to ask this in a fair way? Has something come out of those discussions that was different than when you came in? Do you feel like you're in a different space now, or have you put together a presentation to get through what we asked you to do?
Repeat the question. No, I think the marine science as a signature research area should be much broader, just the science and engineering. It should have the social, the economic component, and strongly. And working with Paul Anderson, the SEAGRAM, the marine extension team, play a vital role in this, consortium. And without them, we don't know how to reach out to the stakeholders. The school marine sciences do not have those networks, the connections, either the engineering. I don't think the engineering has that connection. Therefore, make sense to make much broader the consortium correlation, just the engineering and school marine sciences.
Okay, great. Well, thank you. Next we'll be hearing from STEM Education Research, and Michael, are you going to be the designated speaker? So Michael Whitman will be our speaker this afternoon.
This should be good.
Two jokes?
I do have another joke. Not to give that joke. Okay.
Hi, everyone, and thanks for being here at 5 o'clock. Wildly impressive first presentations, and I hope that we can join the crowd for an interesting conversation. I'm Michael Whitman. I'm the soon-to-be department chair in physics. John Thompson is my colleague from physics. John Shumwell is from the College of Education and Human Development, and I'll name a couple of names further on. We're all involved in STEM education research, science, technology, engineering, and mathematics education research. And since some people may not know exactly what it is, it's probably worth a short summary. What we do is we start with disciplinary knowledge. So knowledge in the individual disciplines, highly specialized. I'm a trained physicist, and others are trained biologists, and so on and so forth. It takes deep understanding of a field in order to study what the students in that field are doing as they are sitting in our classrooms. Along the way of doing this kind of work, we study various learning environments in which we are testing out various ideas about what teaching and learning should look like. Of course, there's a teacher at the front of the room, and you can't treat the learning environment independently of the teaching forces that are involved. And these teachers are making choices about instructional design and about the materials that are in the classroom, all forming a relatively complex system that happens to dominate our children's lives. For us to do research in this area, we use a variety of tools to study their learning both quantitatively and qualitatively. And from that, we then establish some principles of STEM teaching and learning, which can guide our decisions about instruction in the classroom. On the University of Maine campus, I so wanted to make a nice Venn diagram like all of you guys are doing, but we didn't. Ours is just a list. And so we have participating units from across the university sciences, and some of them are larger, like Climate Change Institute we heard about. The Rise Center brings a bunch of folks together. Some are departments and so on. And We come together regularly, collaboratively on grants, and also through the education of our graduate students, where we work together on education research theses or dissertations in College of Education and Human Development, the Master of Science in Teaching, which is, I guess, out of the grad school, PhDs in the various disciplines while specializing in the education and teaching and learning within that discipline, and the newly formed PhD in STEM education that brings many of us together in the College of Education. This work, these publications with both undergraduates and graduates, have led to publications in a variety of prestigious scientific and mathematical disciplines. So science and PNAS are big name multidisciplinary journals. We also publish in Genetics or the American Journal of Physics or the Physical Review or Chemical Education. So we cross the disciplines and talk directly to our discipline colleagues on the one hand. On the other hand, we are also talking to the science education specialists in both statistical work, classroom teaching, teacher preparation, and this work is often done with distinction. The National Academies had a very influential report on discipline-based education research. This work is now guiding much of what's happening at the National Science Foundation in terms of their education outreach. And in this report, 4 of the researchers here on campus were cited in prominent ways. And the articles that we have published have been, have won awards, have been highlights in journals, and been editor suggestions, and so on. Funding-wise, recently we've been on a tear. We have pulled in some money. It's a slightly different funding situation. Most of our funding goes toward personnel, and pretty much only personnel. Our equipment is kind of cheap in comparison to what many of you are working with. And this funding has come from both the National Science Foundation and in the past from the Fund for the Improvement of Post-Secondary Education, so FIPSE. We also get money from the federal and the state departments of education. And we're also getting money from various private foundations, Spencer, Hewlett, HHMI, and so on. Now, the reason that we're doing all of this work, especially locally, the reason that this is important to our local world is if you look at Maine as a state, then this map doesn't really convey appropriately, in my mind, where the people are. And a map of the school districts does a much better job. You can see the unorganized territory, and you can see the various dark outlined areas are meaningful school districts. Those that are colored, in a way that makes sense to some of us working in some projects, but those that are colored are areas where the University of Maine is active and doing research work in the classrooms of teachers or with teachers and using the results of our education research to improve classroom learning in those physical science and physics and science classrooms. Furthermore, as one of our degree programs, the Master of Science in Teaching has graduated students whose thesis work was in education research, and these folks have gone nationwide and worldwide actually, but those that have stayed in Maine to become high school teachers have gone all along, all through the state. You can see the nice strand of the Penobscot River in there too. Why this is important is that Maine, for being as rural as it is, only has about as many people as San Antonio. I was just at a conference this week in Austin, and it was pointed out to me that Miami-Dade has 2.6 million people and 1 superintendent. We've got 200 some superintendents and half that population, and a pretty small area. In our region, the people that we are working with closely as we work in the K-12 classrooms, these are some of the poorest counties in New England. And the teachers that we're working with come typically with not much preparation in the physical sciences, not many degrees in that area. And so as we work with them, as we try to find ways to improve the teaching and learning of the sciences, we have a direct impact on the children and the workforce, the future workforce that's going to jump into all of the other things that have been presented so far this afternoon. So our focus is not on the industry and the work that comes after college. Our work is often on the work that comes before college. And it's education research-driven, evidence-based reform in the classrooms of Maine. We're working in partnership with the Maine Department of Education, the CERC Institute, so that's the Scudic, it's the Education Research Center in the Scudic Institute, Gulf of Maine Research Institute, Jackson Lab, Maine Math and Science Alliance, Institute for Broadening Participation, the Maine STEM Collaborative. These are all partners in this work as we are working at the state level. In addition to working at the state level, we're turning research into practice and changes in education here on the Maine campus as well. I'll just give 2 examples, though there are very many more. We are doing faculty incentive grants where we're working with the faculty up in the upper right corner, and we are bringing some level of reform to classrooms throughout the STEM disciplines. And in addition to the faculty incentive grants, which are being studied, which are being researched, which are being revised based on the results of research, we're also bringing undergraduates into the classroom as Maine learning assistants and studying the impact of these undergraduate learning assistants as they work in the, in case the font's too small, following departments across the STEM disciplines. So, keeping the presentation a little shorter, I suppose. The foundations of this work come from work that existed already in the Physics Education Research Lab, the Math Education Research Group, Chemistry Education Research, Science Education Research Group, and the RISE Center. Building on this foundation, we have a strong set of faculty at near critical mass in very many departments. We have a history of promotion and tenure, of successfully working through and sustainably building these programs. We have facilities that we can use here on campus, various teaching laboratories, various facilities that we can, that bring us all together. And our frontiers are a sense of moving toward a greater interdisciplinary work and growing a faculty that allows us to do more of this work that assists the innovations in teaching and learning here on the main campus, as well as the classrooms in the schools around us. Thank you.
This is super important stuff, and it's really nice to see the university recognize this. And my question is not intended to create concern, but in a previous life, I held an upper-level administration position at an institution where it became really apparent to me that while everything represented by STEM was very important, so were other things. And it's my understanding that one of the new ways of talking about STEM is ASTEM, arts, science, technology. And I'm not suggesting that you need to make a big jump, but I wonder if that's something that's worth considering for the future.
So, my colleague Natasha's in the back of the room, and when she first arrived here on campus several years ago, she and I, and I'm trying to see if someone else is here, we put together a group that was not just us in STEM. She's in math, I'm in physics. We had folks from chemistry joining in as well. But we also had folks from psychology, from English, and other departments. And we were all just interested in good teaching and learning from a research-driven perspective at the college and at the earlier level. And we had great conversations about that. I think there's a huge opportunity for more discipline-based education research, not just in STEM, but in all of the areas. Not just in the arts also. I know that NSF just took its MSP, Math and Science Partnerships, offline, but the new STEM C grant is there, and the C stands for computer science. So there's a new push for computer science to be involved in these discussions as well. So I think there are a lot of opportunities for further discipline-based education research where specializing in your field is a necessary component to being able to reach out and collaborate with other folks, while having at the same time the generalized knowledge that's a broader science education understanding that allows the conversations to be informed. That's where the productive collaborations are occurring for us right now.
Michael, I would add to that, my name is John Cuomo. I would add to that, though, that I think STEM is an area where, even though there are other opportunities and other areas of education research, this is an area that we just have a critical mass we can work with. And if you just look at the other signature presentations, it just makes sense. So your presentation, you gave Climate Reanalyzer as something that is an important thing that's been developed here at the University of Maine. And our group has been working with schools using Climate Reanalyzer, 9th grade students, learning how to build models of climate systems with respect to surface weather patterns or surface air patterns. And so that the opportunity is there, the critical mass is there, so that I think this area of STEM is particularly one that we really should capitalize on.
Any other questions?
Your turn, Michael. I'm curious what you think about the fact that STEM education research has been suggested to be a signature research area, but STEM education itself is only an emerging area. Or potentially an emerging area.
Right.
Do you How do you see that differentiation, and what do you think about that?
I think that the two fields interact very closely in the sense that the results of education research can often be applied very quickly into the classroom. Some of the work that we do is just plain basic research, and it is about the process of learning a scientific idea or what it means to have a conceptual or operational understanding of a thing. And so that's something that is in and of itself an interesting result and a bit of just basic knowledge building. But once you have that, it's another research step to take that knowledge and to apply it in the classroom and test out those ideas. I think that there's an opportunity in front of us to connect the research results more deeply to the education that's happening on campus, and to do it in a way that matches to the needs of our institution and the schools in our vicinity that we can work with. So I do see that there's an opportunity for increased interaction in those two areas. That's, I think, the best answer I can give right now, briefly. I'd love to have a beer for longer conversation. Okay, with beers. So.
Thank you.
Gladly.
Next, we'll be hearing from Habib Dagher and his group in Advanced Materials for Infrastructure and Energy.
Oh, you guys are good here?
Now, being the last one to talk, I can talk as long as I want.
Okay, Carol.
If anybody has a joke to share, we do.
We tested this before, so it should work. What an impressive set of presentations a little earlier. I was very, it's wonderful to see all these wonderful things going on at UMaine. It makes us all proud. So thank you for taking the time to present your work at UMaine. The title of the talk of the proposed area is the Advanced Materials for Infrastructure and Energy. We've been at it since 1996 on developing advanced materials that apply to a variety of applications. We're going to focus over the next 5 years our efforts specifically on two areas: infrastructure, civil infrastructure, and energy applications. How do I bring advanced materials into these two particular areas? This is a picture of the first offshore wind turbine in the United States. It was built in our lab at the University of Maine. I'll talk about that. It's the first in the world that has a concrete foundation and a composite tower. And it was built by over 30 different companies working with us in our laboratory and deployed successfully. Been around for almost a year. May 31st will be 1 year. We'll have our 1-year anniversary of successful operations in the Gulf of Maine. So what I'll talk about today is the center itself. If you don't know who we are, I'll tell you a bit about who we are. Some of our metrics, what have we been doing out there over the last 15 years. I'm going to tell you about two specific projects. Because we do about 50 at any point in time. There's over 50 projects ongoing in the lab, but I'll talk about the civil infrastructure project example and an example in energy. And then I'll talk about what we plan to do over the next 5 years. What are the investments we're looking to invest in? The Advanced Structures and Composites Center was an NSF EPSCoR grant that started back in 1996. And I'd like to acknowledge Steve Shaler up there, who on the back of an envelope and I started talking about building this. Larry Parent, are you there? Are you here? Larry, and Krish in the back, thank you. And of course, without Dana, who's worked with us for many years as well, allowed us to get to this point. We have about 200 people who work in the lab, about 50 to 60 full-time folks, and about 140 or so students who get paid to work in the lab every year. We've financially sponsored over 1,400 students that have worked in the lab since we got started. And what do? We bring advanced materials into construction. How do I build it faster? How do I build it cheaper? How do I build it with a smaller environmental footprint is what we do. So What are the focus areas that we work on? We have 5 areas, strategic areas that we work on. They're all integrated in some ways. We start with civil infrastructure. This is buildings and bridges, how do I build better buildings and bridges that last longer and so forth and lighter. Wood composites, you've heard about that from Hammett. Defense composites, how do I use advanced materials to protect troops, for example, from ballistics and blast loads and others. We've done quite a bit of work in that area. Nanomaterials and nanocomposites, and offshore wind we've been doing quite a bit of work on as well. And we do a lot of testing for industry. So we bring companies through the door first to come use our large facilities. And once we bring them to the door, we hook them so that we could work with them on a variety of very exciting projects over many years. Our center has received global industry awards many times over for a variety of projects we've worked on. ACMA is the American Composites Manufacturers Association. They're the largest composite manufacturers association in the world. They have 4,000 members. And for 4 years, we've received the top awards for products developed here in the laboratory. And the American Society of Civil Engineers has given us the top innovation award in the world in 2011. It's called the Charles Pankow Award for the bridge in a backpack technology. It was selected as the top development in civil engineering in the world at that time. This is an example of a technology we've also worked on in infrastructure. This happens to be boat and boat building. Maine, as you know, is a big boat building state, so we've done quite a bit of work with the boat building industry. And this is part of infrastructure. This is a boat for the U.S. Navy SEALs. The Navy SEALs have a boat called the Mark V. It's a high-speed interceptor that's 83 feet long that can go over 50 knots. The purpose of that is to catch the bad boys and girls fast and to be very maneuverable. The problem with it is it's an aluminum hull boat. Think about an aluminum thin hull boat going 50 knots in 4 and 5 foot waves. The wave impact forces on the hull were causing 10 to 20 Gs of forces in the hull, and those shock loadings were causing damaged, shattered molars for the SEALs. As tough as they are, they were breaking molars, and they were damaging their bones in the legs. So we partnered with a company in Maine called Hodgson Yachts, and worked with them on a new hull design that's more shock absorbing, made out of composites. It's a sandwich hull that has carbon fiber and Kevlar. We designed it in the lab, partnered with them. The Navy liked what we've done in the lab and gave us $15 million to build the boat. And we delivered it on time and on schedule with a company called Hodgson Yachts in Maine. And they spun off a new business called Hodgson Defense Composites. They're producing this and other types of structures. On the bridge side also, that has spun off to a business. We have a company called Advanced Infrastructure Technologies that is producing these bridges right now. And last year, they've been approved in all 50 states in the country. So they're looking now to try to grow the company beyond where they started. So these are examples of things we've worked on. But in terms of metrics over the last 10 years, we've brought in over $100 million of research to the university over the last 10 years. We've had over $14 million of industrial contracts. We have over 300 companies that send their money to Maine from across the world to do research and development in our lab. We have over 87,000 square feet of lab space and about to expand one more time. We have 26 patents, 447 papers published, 29 national and international awards, 31 different departments and units on campus have collaborated with the program. And we've been, in 2013 alone, we've had over 500 media stories nationally and internationally. So we've been around, people know about us. This has more details, you can read about them, I'm not going to go over the numbers. In terms of external research funds, this is a line that shows the funding per year. We started out near about $3 million a year in 2000, and we've peaked in 2011, and now we're about $8.5 million this last year. And notice that the number of faculty that work in the center has stayed relatively steady, and so we're about 11 to 14 faculty members. So this is a heck of a number of productive faculty members that bring all this research money to campus. In terms of lab space, we've been growing our lab steadily over the years. We started with about 31,000 square feet. We're 87,000, soon to be 100,000 square feet. But again, the number of faculty hasn't grown either, so you can see where I'm heading. We need to get more faculty into the center, and that's one of the proposals here. That's why we're proposing this. I'd like to talk about this project in the context of how big the market is that we're going after. We're going after the civil infrastructure market with advanced materials. How big is this market? It's over $1 trillion a year in the United States alone. This is building bridges and buildings and so forth. So one of our solutions is the bridge in a backpack. This happens to be the New York Times. They ran a whole story about our bridge in a backpack, a whole page on it. And they did a very nice drawing, which I didn't have to pay for, which is nice. It shows you what the bridge looks like. It comes in the University of Maine hockey bag. I tend to say University of Maine hockey bag when we win. And when we lose, I say a hockey bag. But anyway, we can actually, each one of these arches fits in a hockey bag, can be inflated on site or shipped to the site, filled with concrete, and these bridges can be built very quickly. The second bridge we built using this technology, we're able to build in 12 working days. Okay, this is from taking the bridge out. This is a 2-lane roadway bridge. Took the existing bridge out, put the bridge in. From shutting down the road to opening the road to traffic was 12 working days. And you can see why these technologies are important. And the bridge lasts a lot longer than traditional construction. We're looking at 2 to 3 times the typical life with very, very little maintenance because of the composites that we use in the bridges. So these are the kinds of technologies. We also were very happy 2011 to have tested and helped design the longest composite bridge in the world. And you can see it right here. It was built in Maine. It started in our lab as a bridge that was tested to prove to the DOTs that this stuff really works. Composites will hold up the load. And they became believers and paid to build a 540-foot long bridge, which currently is in Maine and is the longest composite bridge in the world. To give you a sense of why this is important, these are composite girders, and they're 1/6 the weight of steel. So think about the equipment you have to bring to the site to build a bridge, a lot less. Plus, you've got very poor soil conditions because so you have a lighter bridge, you need less foundations, and plus it's corrosion resistant compared to steel and it'll last longer. So these are the advantages of some of these materials. I'm going to show you an example of an energy project we're working on to give you a sense of how we put our projects together. This happens to be our offshore wind project. The reason we'll get into that is we have one of the best offshore wind resources in the United States off the coast of Maine. If you travel from Florida to Maine, the wind offshore gets to be better and stronger. And when you get to Maine, we have these red colors, which are the best winds. Notice in the northeast United States, we have very, very good winds. We pay the highest electricity costs in North America, and we have 55 million people who live between Maine and New York. So the plan is to be able to generate electricity in Maine and ship it to this marketplace and create jobs in our state. Just like we ship the potatoes, just like we ship lobsters, we can ship electrons produced in the state of Maine. That's the purpose of this activity. To give you a sense of how we work together, we have over 30 partners, industrial partners and university partners, just working on this particular project with us. And they're some of the best in the world. To give you an example, Iberdrola is the largest wind developer in the world. You know about Chimbro with 4,000 employees and others. And this offshore wind program started out by a committee that the previous governor had put together, that I served on, and that proposed putting 5 gigawatts of offshore wind in the Gulf of Maine in the 2030s. That's 5 nuclear power plants worth of wind. This would be floating wind turbines that would be placed over 20 miles offshore that you don't see from land. The question is, how do you build them cost effectively? So we put together a plan to get us there. It's a 5-phase plan that started with research at the university, deploying a 1:8 scale, deploying 2 full-size turbines, and then starting in the 2020s, build larger farms. So when people tell me, when you have a bump in the road, does that bother you? Of course it bothers me, but I'm looking at a 20 to 30 year time frame. So a bump in the road is okay. And we've seen a lot of them over the last few years, and we will keep going to make this happen. So 5 gigawatts of offshore wind by 2030, that's about a $20 billion construction project. Think about the jobs we could create if we can harness that kind of energy. How much wind is there off the coast of Maine? There's 156 gigawatts of wind. That's enough wind capacity to power the state. The state of Maine uses about 2 gigawatts of energy of electricity. Think about, you got 156 gigawatts out there of offshore wind. So it's enough energy to power the state, certainly 50 times over plus. This is how we built the first prototype. We built it in our laboratory, the offshore wind lab, using our staff and industrial staff working together hand in hand to do this. We went on May 31st of last year to Brewer, Maine, assembled the unit. This is all made out of concrete. The hull is made out of concrete. The tower is made out of composites. You can see we had a crowd on the day we put it into the water. Over 800 people came, and we placed it in the water in the Penobscot River. We had a congressional delegation out there, towed it down the river, and under the bridge. And we also worked with the School of Marine Sciences. Thank you very much with the team out there to build the first floating LiDAR that was deployed on the North Atlantic. And that's a LiDAR built in our lab that allows us to measure wind speeds at hub height by using lasers. And that was deployed simultaneously with the turbine. And after a year of testing, we've seen events that exceed 100-year return periods because that's a 1:8 scale unit. This unit has over 60 sensors on it, and the maximum inclination angle it's seen over that last winter was 5.9 degrees. Okay? And the maximum acceleration it's seen is 0.165 Gs, which is very minimal during that environment. Blue and red are comparisons of our model data to the actual data measured at the unit. We worked across campus with a variety of departments to do this work. This is visualization work to see what it would look like from shore, from Monhegan Island looking out at our test site. You can see how tiny the units are out there. And we've worked with the biologists on campus and beyond to look at potential impacts on birds and bats and undersea life, as well as looking at impacts on communities and so forth. So there's a lot of work that's going on beyond engineering to ensure that this works. This works. So it's truly a lot of us all over campus coming together to make something like this happen. So it's been great working with everyone. So what are our big challenges? Is we're getting old. A lot of us are doing other things. So these are the original faculty that worked that have started with the program. The ones in red are the ones that are getting old and leaving. Me being the very first one getting old but not leaving. I'm the director of the center, so I can't do as much research as I love to do. Bill Davids became chair of civil engineering. Eric Landis is chair of mechanical engineering, and Steve Shaler is the director of School of Forestry. So 4 of us initial culprits getting this whole center together are now doing other things. And so we're challenged to continue to what we do without investments in faculty. That's really what we're trying to say. So what is our plan moving forward? Our plan is the proposed investment over the next 5 years. We're building, starting in June, hopefully the end of June, beginning of July, working with Krish and others, the first wind wave facility in the United States of its kind, or the first one in the world. It's a wave wind basin funded by $8 million using 3 grants. The National Science Foundation grant of $1 million, an EDA grant, the Department of Commerce of $3 million, and a bond of $4 million. So that facility has been designed. We're going to break ground to do this. It's going to allow us to think about a wave basin, a wave pool, but you have a open jet wind tunnel on top of it that you can change directions on. So it's a wind tunnel on top of a wave basin to allow us to test various facilities, wave, wind, and other generation facilities, as well as boat building and others. Very exciting facility will come on board here, hopefully in about a year from now. What we propose to do is a $2 million investment in equipment to finalize equipping this facility in the next 2 years. We're also planning to add a robotics manufacturing facility to this building to do robotics manufacturing composites. We have $2 million in the bank for that. We'd like to go after a state bond over the next 3 years by 2016 to bring more equipment into this facility. So that's a specific goal that we have. We'd like to add faculty, particularly to replace old people like myself. We're looking at 2 faculty positions over the next 2 years or 3 years. One is in thermoplastic composites, one is in robotics manufacturing to allow us to do this kind of work. And then we'd like to go work with the state to provide operational support for our offshore wind test site of $3 million a year between 2015 and 2022. There's legislation already in place to allow us to do that. We just have to work to make sure we put money behind the legislation. So there are specific things over the next 5 years that we'd like to accomplish. And finally, this is one of my most exciting videos. I have to show it to you. If I can turn the lights off. This is what the turbine looked like off the coasts in one of our latest storms called the Storm Electra. This is a storm that shut down electricity throughout the state of Maine, and that's in December. The waves were over 50-year return period waves compared to the size of the unit. And notice this thing is floating, yet it's barely moving at all in a 50-year event. So that's the kind of, so we have proof this stuff really works. Now we're going to go out there and do more work and build some bigger ones. And that's where we like to head. It's nice to look at it right now, but before these storms come in, none of us sleep at night because we weren't sure if it really works. Now we know it does, so we can look at these videos and be happy. So. So I'd like to thank you for the opportunity to present this. I want to thank the support of the university for many years. Thanks.
Questions for Habib?
Sure. Habib, I'm curious, certainly no one questions the success that you've had for years with you and your colleagues. It's been wonderful to see in my time here. But I'm curious if you could talk a little bit about the ways in which moving forward these programs would benefit the broader university in terms of ROIs and in terms of increased student numbers?
Very, very good question. And I think the biggest thing we can do, all of us can do, is find a way to bring more undergrads into our laboratories and advertise what we do to undergrads so they know what's going on in these labs. You know, all of what we've talked about are very, very hidden gems, if you wish. All of the areas you heard about today. As much as we try to get them out there, we've done a lot of work to try to get them out there, but how do we tie these research areas, these wonderful areas, to how we advertise ourselves as a university to the rest of the university in the world, to bring more of these students into these laboratories. Provide opportunities for students, if you wish, for scholarships for students to come work in all of these different wonderful areas we've all heard about today. I'd like to see us maybe put a campaign together that would specifically target our alumni to say, look, we want to bring these wonderful students and put them in these laboratories and advertise that all across the country and the world. That differentiates us, if you wish, as a university from the other universities in the state. So that's what I'd love to have 5 times as many students in this lab as possible that go through this lab. And it's a great way to advertise this university. That's, I think, would be the best thing I would try to do. Now, in terms of ROI beyond the students, certainly the ROIs you've heard from all these projects has already in many ways taken place. So I think focusing on the students and bringing more students in is the biggest thing I'd like to try to do. That's still kind of a missing gap.
I mean, I was just going to ask you to, if you wouldn't mind, help us understand this recent bump in the road and sort of give us some context for understanding what it means for you.
Sure, thank you. You know, Winston Churchill had a very famous saying. He said, "Success is keeping focus between failures." And certainly that's a bump in the road for us in terms of moving forward. We had been down selected from between 70 programs to 6, and we were given $4 million last year to do some design work, and went out there at DOE, and then they didn't select us as part of the 6. Looking back on what they did or what they did not, it really became clear to us we had more innovation that they were willing to bet to gamble on in a short time. We're very unique. We have the most innovation. They've told us that. This is something they've told us. You've got way too much innovation they were very concerned about the Cylindra effect, if you wish, at DOE. However, they are still going to fund us for $3 million next year to complete the design, and told us we are an alternate in the competition. So there's still an opportunity for us to go back into the competition over the next year if we answer the questions, which we think we can. We don't think they're not tough questions. And then also if any of the other projects drops off, then we can get back in. Or if they can get more money into the program, we can get back in. I was also in Texas last 3 days. Just got back from Texas talking to private investors that could potentially also do this. There's a lot of interest from private investors as well. So it's just a bump in the road. I think like anything else that we do, we just have to keep working hard and even harder and make sure it'll work. And that's our commitment. So, thank you.
Any other questions for Habib? Ellen?
I guess getting back to the question that Owen asked, and I wondered about, you have a couple of faculty positions up there that you were interested in, and it seems to me that getting, what you were saying across all of these programs is getting students in the labs and kind of, they are hidden gems in that we don't do that. Most of the way that students they experience this campus is through the classes that they take. And so do you have ideas about how you could, how do we introduce projects such as yours? How do we integrate them into the classes that our students are taking? So, rather than, because I think otherwise when they're positioned on the outskirts of campus, the students don't realize that there are these tremendous opportunities for them.
Excellent question. You put your finger on it. We've made a significant effort to try to bring as many students as we can into our lab. And as I said, we have 140 or so students every year that get paid to work in our lab. So how do we do more of that? What we've tried to do most recently, we've tried to take one of our projects and make it a capstone design project for the seniors in the class and in civil engineering. And that worked very well. The industry members who are actually working with us actually became the consultants to the students. And they did a whole capstone project, which won, by the way, the capstone design competition for the students. So taking, if you wish, some ideas in our laboratories and making them integrated into the curricula as capstone projects, finding more money from foundations that can allow students to come work in the lab and get paid to do that, that's something we can do. I know we can. So yeah, integrating the curriculum, finding more money from foundations. I don't think we've scratched the surface yet in terms of what we could do with foundations on this campus. And they're very interested in education, whether it's STEM and others, and working with the STEM program. How do we bring some of the high school students as well is very important. We've put together a program that last year brought 500 students and teachers under a competition to make wind turbines and to make floating wind turbines. So that's part of what we try to do to bring some of these students in. But we're limited in resources. What we need is a concerted effort where we can go after foundations, bring people in whose job is specifically to go after opportunity to bring students into not just our lab, but all the labs on campus. So these are just some general ideas. I hope, and we can talk some more, I'm sure.
Well, I think it was several years ago when I took over a class that Mark Anderson had been teaching, which was EES 100. So 140, 50 students, in per semester. In every lecture, he ended with something that related to what he talked about, other courses, upper level courses that students, if they're interested in this, would take, as well as other opportunities on campus about what students use. And I just think we should think about more ways that we can do things like that, that introduce all these great things we've heard about today to our students in the early classes that they take.
Exactly, or even before they come to you.
If we rely on them just getting to the outside corners, I think a large percentage of our students miss the opportunity.
Absolutely, absolutely, amen. Very, very important points, yes. Thank you for bringing that up.
Thank you.
Thank you.
So not surprisingly, another hour and a half of fantastic presentations. I am again impressed and very proud of the connections, the projects that were presented today. So I guess we'll have a similar forum in the next couple of months for the emerging, and hopefully we'll see you all there. So thank you for your attendance, and please join me again to thank the presenters.